Okay, this tutorial is going to help you answer an exam question where you are asked to explain the formation of a meander. And it deals with this part of the checklist where you're looking at formation of erosional depositional features in a river landscape. And there are 4 features you have to study. My suggestion would be that after you've watched this video on the meander and maybe made some notes, is also to then go straight onto the Oxbow Lake, because there is a strong connection between an answer you write for the meander and the Oxbow Lake. Now, what a typical question is going to look like, if we just have a look at the past papers, will be something like this, which is just going to pop up in a second, which will say, explain with the aid of an annotated diagram or diagrams how a meander is formed. This type of question, whether it's the meander or the waterfall or the V-shaped valley or the Oxbow Lake, can be worth anything between 6 and 8 marks. And you'll notice in every question there is a requirement to, certainly in these 3 examples, to use a diagram, but in this question it says you may wish. Now you must pay close attention. Are you either being asked to use the diagram, as in this question here with the aid, or are you being given the option? If you're given the option, you can choose not to, but if you're required to, like in this question, you must. Now, what does a diagram have to look like if you are being required to draw a diagram for your meander? Well, in order to ensure you can get full marks, it has to be a very, very simple diagram. I'm just going to show you. You could literally draw this diagram here, label on the inside of your river bend the deposition, maybe inside bend, and on the outside bend and erosion, and just have that. Don't bother with anything else. Maybe put the arrows in to show the fastest current, but that's it. You don't need a sequence of diagrams. You need a diagram with one significant label that is linked to the meander formation. And whilst you will not get any marks for the diagram itself, you will be able to access the full range of marks because you have complied with the question. You may, however, choose to look into your class notes, where you'll see that we've drawn a sequence diagram for meanders, and you may choose to use the annotated diagrams method rather than writing anything, and you can still get full marks if you take that approach. What I'm now going to talk you through, though, is as if you were writing this out as an answer rather than drawing a sequence of diagrams. So let's get started by thinking about what is the meander. So the meander, if I just jump down here, is a bend in the river, so we can see the current coming towards us, where the river is deeper on one side, and that would be what we call the outside bend. So this would be the outside bend here, and up here is the outside bend. And it's shallower on the inside, which is what this bit here and this bit here is. It's where the river has one steep riverbank, known as the river cliff, and it has one shallow, narrow, gently sloping riverbank called the river beach, or technically called the slip or slope. It's also a point where the river is moving from pools, which are areas of deeper water, to riffles, where the river is shallower. Now, we haven't yet written anything. The first thing you're going to write in answering a question of this nature, just bring up another. Is you're going to want to start by talking, the very first sentence will be that a meander is a bend in the river, and it forms where the river starts to flow on a gentler gradient when it's closer to sea level. And what you're going to get marked for saying that, as long as you then say which encourages the river to do more lateral erosion. And now, just so you know, lateral erosion is where the river channel starts to shift sideways, eroding laterally across the landscape, or you might call it horizontally, rather than vertically, which is what it's doing in the upper course when it creates the V-shaped valley. So in the lower course, which is where these meander bends are formed, it's starting to erode laterally. Meanders, next point you want to tell me about is where meanders actually start to form where the river moves from pools to riffles. Now, all you want to say here is that a pool is a deeper area of the river channel, we can see it here, and a riffle is a shallower area of the river channel. Now, when you're looking down like a bird's eye view, you won't be able to see the difference between a pool and a riffle, except there'll be more disturbance on the surface where the riffles are, because there's more friction. So if you tell me about a pool being deeper and a riffle being shallower, you'll tell me that because the pool is continually changing, the river is continually changing from being more efficient and fast flowing in the pool to less efficient with more friction in the riffle, this starts to cause the river to move from side to side across the channel. And the fastest flow is what we call the Thalweg. And it's doing this in a helicoidal motion. And that's helicoidal motion is a corkscrew motion where it's corkscrewing back and forward across the channel, and it's doing this because it's moving between pools and riffles. Now that's really important to establish that that's what's happening, because that then leads you to explaining why is, instead of the water just traveling straight down, why is it moving from one side to the other? So now that you've explained why the fastest current, the Thalweg, is moving from one side to the other, and it's to do with this difference between pools and riffles, you then move into the second main part of your answer. Now, for a lot of people, this might be quite near the beginning because they might not be confident talking about pools and riffles. And I certainly recommend you look into your class notes to get a bit more detail on that if you're not sure. But if you've got to this point and you're reasonably secure and you've at least told me that, at the very least, if all you know is that the river starts to move across the channel in a zigzag pattern because of its helicoidal flow, and this occurs because it moves between pools and riffles in the channel, then that will be enough, and that'll get you a mark in itself. This next bit, you can stack up the marks really quick. Because the fastest flow strikes one riverbank, and therefore is not striking the other, so we can see here that the water is going to be striking here and not here. I'm just going to move on to the diagram to show this. There's going to be, all of the current is going to be hitting one side of the channel more than the other. So we can see it coming here and hitting this side, and then zigzagging across and hitting this side. Now, because most of the flow is hitting one side, it's going to encourage far more abrasion and hydraulic action on this side than on the opposite side. Now, as soon as you say the word abrasion hydraulic action, what that should then trigger in your answer is the next bit, which is where you tell me what abrasion and hydraulic action is. So you would tell me that abrasion is where the sediment and the rocks being carried by the river scrape along the banks and the bed and increase the rate of erosion where they're scraping. Now, this is much more likely to happen on the outside bend because most of the rocks are going to get pushed to the outside bend because of the faster current. On the outside bend, there'll be a lot more hydraulic action because the increased amount of water is getting into cracks on that riverbank, and it's pressurizing the water in those cracks, and the air becomes compressed in those cracks, expands, and eventually creates a larger crack, and the riverbank will eventually get undercut. You can see this word here, and collapse, and then the fast flowing current will wash it away. Okay. Now, whilst that's happening on the outside bend, we have increased rates of hydraulic action and abrasion. And if you fully describe hydraulic action and abrasion, you'll get 2 marks. If you name them both, you'll get a further 2 marks. So if this was an 8-mark question, 4 of your 8 marks comes from naming hydraulic action and abrasion in your answer, and then telling me what the 2 of them mean. So we have this fastest current on the outside bend, lots of hydraulic action and abrasion over here. On the opposite side, there is very little water movement, and therefore the water has far less energy. Therefore, on the inside bend, it's going to have a tendency to drop anything it's carrying because it doesn't have the energy to carry it. So any sediment and mud that's being carried by the flow of the current will get dropped on this inside bend because of the lack of energy. That will build up over time to create a gently sloping bank known as a river beach or a slip-off slope. And it will be directly opposite the other side where you have a steep riverbank called a river cliff created by the undercutting of the fastest flow. Okay. Now, I've given you a full explanation with lots of details for the creation of a meander. You will want to make sure you have a sort of at least a very basic rehearsed answer for a diagram with 1 or 2 simple labels in order to ensure that you could get those marks. And if you've listened to this video, you should probably now move on to the Oxbow Lake, because the Oxbow Lake is just the natural progression of this answer that I've just explained.